Excellent. All right, time to start. Now it's gonna give me a hard time to start. Come on, YouTube. All right, we should theoretically be live, but as always, I require some kind of external validation, some sort of evidence that I exist. So once we've been observed, then we know our wave front has collapsed and the show may begin. There we go. Someone told me that I exist, so I can only
Excellent.
assume that it's
External validation.
external
Thank you.
validation. Yeah, it's one of those quantum mechanics kind of things. Hey everyone, so my guest today is Geoff Notkin. He is the host of the Meteorite Men and the new president of the National Space Society. There, get off my back. I just explained who my guest is. Now I can shift into the more slower kind of introductory approach. Geoff, how's it going, man?
It's going extremely well, Fraser. It's very nice to hear your voice in real time.
Yeah,
Again, thank you for inviting me to be on your show.
glad to have you. We met for the first time in Australia almost a year ago. It was July 2018. We were at a great festival, astronomy festival in Australia, both giving talks. It was the first time we met, and it was
It
just,
was.
and it was love at first sight. We had a great time, a great chat across a range of subjects, and my hope is that we can just capture just like a little bit of that magic today.
Oh, I'm sure
So,
we can. Thanks.
yeah,
That's was a lovely intro. And of course, you and I had been social media friends for years
yes, yeah.
and supporters of each other's work, of course, for
Yeah, but
many
it's
years.
one thing to like see a person's tweet, and it's another thing to actually hang out in public and be able to interact face to face. And we never get a chance to do this, right? Like as people who all live scattered across the planet, we never get a chance to actually hang out in person and interact. And it's my great sadness because I live in this beautiful paradise, Vancouver Island. It's such a pain to go anywhere off this place. And yet, when I do, I get a chance to go to conferences and stuff, and I have such a good time hanging out with people. So I haven't solved this. Some kind of teleportation system, holograms. It needs to be cracked, I think.
Surely that's on the way. I mean, have you heard of the show Star Trek?
Yeah,
They seem to use those things all the time.
yeah. So who are you? What do you do?
I'm a bit of an oddball, really, Fraser. I think you already know that. We hang out in Australia. As you said, we met in Australia. We met in a strange, beautiful outdoor dining area at a very magnificent resort on the Australia coast, where we were both speakers at a marvelous astronomy event hosted by our friend Dylan. I'm a lifelong science and arts devotee. I am equally fascinated by the sciences and the arts. As you know, and as some of your viewers may remember, for 3 years I hosted a very high energy action adventure science show called Meteorite Men that was originally made for Science Channel but went on to air on Discovery and networks all over the world, tens of millions of viewers. And meteorites have been my passion since I was a kid. So the opportunity to take my interest, my fascination, not just for the meteorites themselves, but for the adventure of finding them to a global audience was a marvelous thing for me. And coupled with my interest in meteorites, and here's the big irony of my life, is a fascination with spaceflight. So on the one hand, I've got this enduring love for the cast off debris of the universe. Well, really the solar system, but it sounds better to say the universe. The cast off debris of the universe today that lands on our planet Earth. And on the other hand, I'm fascinated by the processes of getting humans and robots off the surface of our planet up into space. So, what goes up and what comes down, both lifelong passions for me. And how lucky am I to now be working in both fields at the same time? So after many years of working with meteorites, as first as someone who traveled the world looking for them, and then as a science writer, I wrote I've written articles in several books about meteorites, and then there was a television show and many other television shows. I also did a series called STEM Journals, which was a multidisciplinary science show. I've guested on many science shows from Discovery, BBC, PBS, and all that sort of thing. And I'm Chief Executive Officer of Aerolite Meteorites, which is a commercial meteorite company. We're an international company. Our headquarters is in Tucson, Arizona, which is where we are broadcasting from today. And we also have a European office. And in addition to commercial work, so we buy, sell, trade, authenticate meteorites, provide specimens to collectors and universities all over the world, we're very passionate about outreach. To me, it's never been primarily a commercial enterprise. Running a successful business allows you to have some cash flow, which allows you to do other things. And I choose to do educational, fun, exciting, and informative science and arts-based things.
Yeah.
So, sorry, go ahead.
Oh, I was just going to say, and I mean, I think the part where people know about you the best is just this worldwide hunt for meteorites, which, I mean, is such a wonderful hobby because it's like half adventure, half science, half mystery. All mystery. Where
that's
you
three
are,
halves, though.
I know.
But it is 150%
that's
bigger
exactly,
than
that's all I'm
thing.
saying. Yeah. Half adventure, half science, all fun. And the fact that you are just sort of chasing these legends of meteorite strikes that have happened around the world and then actually getting into various people's backyards with or without their permission to dig them up and sort of find these just treasures from space is great. And for anyone who actually has a piece of metal from space, it is like one of the top things that I recommend. So you sell them.
I happen to have one right here.
Yeah. Is that a stone one or a metal one?
Very well recognized from the video feed, Fraser. Yes, I picked this one because I thought it was particularly relevant to space exploration and space flight. Yeah. So this is a stone meteorite. This is a half individual, or maybe 2/3 of a stone. So this face has been cut off. Oh, what have you got there? There's an iron.
Yeah.
Oh, marvelous.
Yeah, it's getting a little rusty. I need to recoat it, I think. So.
Yes, I'd be happy to advise you on that.
Perfect.
We've got some good techniques.
All right. Well, then I can't wait to find out. But it's so amazing just to have like a chunk of space metal, or in your case, space rock. So what's the story on this one?
This is, we call it a Northwest Africa XXX. It is a stone meteorite, a chondrite, the most abundant type of meteorite that was found in the hot, dry deserts of Northwest Africa. And it has been cut along this face to show its interior. And chondrites take their name from chondrules, the tiny glassy spheres that are believed to have formed at the very beginning of the solar nebula, so prior to any of the formation of the rocky bodies in our solar system. And this type of meteorite, the material of which it's made, these chondrules, has remained largely unchanged since the formation of the solar system in many cases. And so the study of meteorites gives us perhaps the best hands-on opportunity to explore and understand the makeup of other bodies in space. And that's where the meteorite spaceflight overlap really began to shine for me, because I was invited by Rick Tumlinson to join the advisory board of Deep Space Industries many years ago. Because if we're going to mine asteroids, we want to know what the asteroids are made of, and most meteorites come from asteroids. So there's a pretty good Sherlock Holmes cause and effect chain that you can follow back there. If we study meteorites and are able to determine what type of asteroids they come from and where those asteroids might be, we're quite far along the theoretical path to mining usable materials from those asteroids.
Yeah.
But my favorite bit's what you said about the 150% fun and adventure.
Yeah, the digging around in people's backyards, seeing if you can find the asteroid strike. Now, even though most of them are those rocky ones, the ones that you find tend to be these metal ones because they're magnetic, which are weird.
Will adhere to a magnet. Yes, they don't actually have magnetic properties, right. But yeah. The vast majority of meteorites contain a significant amount of iron. And actually, depending on the light, this chondrite, this stone meteorite, even though it's described as a stone, still has about 20% iron in it, and you might see it reflecting in the light there. So we can use some very sensitive metal detectors under certain circumstances to locate this type of meteorite. But if we're out in the field using technical equipment to find buried meteorites, we're more often than not looking for irons, or stony irons. So an iron meteorite, similar to the one that you just held up, typically about 93% iron, and the rest is nickel and trace elements. So if that's buried at a reasonable depth and you go over it with a metal detector, you're definitely going to know about it.
Yeah.
And the stony irons, the pallasites and mesositerites, are about 50% nickel iron. So also can provide a very powerful target to a metal detector. Interestingly enough, though, statistically, the vast majority of meteorites that fall on Earth are stones, similar to the one I was just holding up. That's the most abundant material that seems to be floating around and has the potential to cross paths with Earth and crash into us. So when we go and we investigate recently fallen meteorites, which you might say are the progeny or what's left behind from a fireball, we are usually expecting to find stone meteorites, and usually on the surface. So contrary to what you might see in sci-fi movies and some blockbuster films, most meteorites, I'm afraid, as you well know, Fraser, are not molten and burning hot when they hit the ground. They're actually slowed down through atmospheric braking and various physical processes. So typical impact speed would hit the Earth maybe 200 or 300 miles an hour. So you still don't want to get hit in the head by one.
Right.
Unless you're a robot. Yeah. And even then, that might
still not good. All right, so I'm going to ask you literally the easiest question of this entire interview. This is going to be the softball.
What is your name?
No. Eric wants to know, where can I buy a meteorite so that it isn't a scam? Here we go. Eric asks, where does one purchase a meteorite? I suspect the ones on eBay, etc., are probably fake. Where is a purveyor of meteorites that someone could trust?
Thank you for your question, Eric. There are a number of very reputable meteorite sellers in the world, and there's a wide selection on eBay, but the risks associated with buying something on eBay would be the same for any other collectible. So my company, Aerolite Meteorites, it's Aerolite, AEROLITE.org, is a long-established meteorite vendor. I've been in the business myself for 25 years. And another really wonderful company is meteoritesforsale.com. They're based in California. And it's important, if you are considering purchasing a meteorite, that you go to a company that's very reputable, that is going to give you a no-nonsense guarantee, both of authenticity and return policy in case you decide that you don't like it for any reason, which really doesn't happen. I don't think my customers typically don't call and say, well, I got this fantastic meteorite, but I don't like it. That's just not something that what usually happens is people go, oh, I love this meteorite so much, I want another one or a bigger one now.
Well, so I actually will admit, I love the ones on eBay, and it's definitely a bit of a crapshoot, but I tend to look for people who have a pretty good reputation. They've been doing this a long time, and I will buy collections of the smaller chunks. And then when I go to conferences or when I visit people, I will bring meteorites and then give them meteorites and go, here you go.
Wonderful.
It's a piece of space metal. I generally guarantee a superpower, although a fairly mild superpower, like nothing, like not like flight or anything, but like every time you go for a motorbike ride, it's probably going to be sunny or something like that. Right.
Indeed. And actually, Fraser, could I add another bit of information to the answer to Eric's question, please? Which is, I don't want to just promote my company. There are a number of other vendors who are wonderful. There is an organization called the International Meteorite Collectors Association, IMCA, and this is a global organization of vendors and collectors, and they have very high standards required of you ethically and in a business sense to be a member. So a good way to gauge the reliability of a vendor is to see if he or she has the IMCA badge on their website or their eBay page. And there are many good eBay sellers out there. I'm not knocking eBay, but if you're going to shop on eBay, look for the IMCA badge, or as Fraser says, look for someone who has a long track record. And there's a wonderful gentleman, Mike Miller, who is a very active meteorite hunter for many years, and his eBay handle is Meteorite Finder, and he's one of those guys like me who goes out in the field and does the finding. And then we have the hard part about, I don't know if we're going to be able to sell any of these after the enormous adventure of finding them.
Right, that's the problem, right? It's trying to sell something that you like literally bled over to acquire. But I guess that's part of the game.
This is a very accurate assessment, and I must say, Fraser, that a lot of the pieces that I have found over the years have remained in the Aerolite Meteorites reference collection, or have been donated, or have gone into museums, and I actually have not sold that many of the ones that I found.
Right.
It's like, it would be like selling almost an art creation, or I don't know if I should say selling a child. That maybe not
right.
Quite
so when someone from Argentina brings you a box full of Campos del Cielos, no problem, you're happy to make some of those available on your website. But when you literally had to go and chase a rumor from 1922 into the backyard of someone, then you've got some skin in the game.
Most definitely.
Yeah.
And in some cases, we've spent so long on an expedition that by the time we get to the end of it, even if we make a very significant find, it still may not necessarily pay for the cost of the expedition.
Yeah.
Even in hard costs, that's not factoring in the time of the several people usually who would have gone. So my co-host on Meteorite Men, Steve Arnold, who's been my great friend for over 20 years, is fond of saying that I'm actually his best customer. And the reason for this is Steve and I typically agree to co-own the things that we find. And Steve's an excellent businessman and has been in the business for many years.
And then you have to buy him out.
And Steve's also a dad with children and other careers.
That's awesome.
So sometimes we get to the end of this harrowing 3-week expedition and we found a couple of really good pieces, and Steve goes, I'll cut mine up and put them on eBay. And I'll go, no, actually, I'll just buy your half.
Right.
And keep it. So it's usually a jovial and friendly arrangement. But sadly, I think he may be accurate in that assessment of me being his best customer.
Don't Jim asks, I just bought a book on micrometeorites. What can you tell me about them? Have you gotten into the hobby of micrometeorites yet? I have the same book. Actually, I was looking for it. It's kicking around. I'm sure I will dig it up at some point. But
and could I ask the name of the book that you?
Let me find it. Please. Yeah, they sent me a review copy.
Wonderful, because there are a couple of different books on micrometeorites, and I know there's one that's come out recently that I have not seen yet, but from photographs looks fascinating. So micrometeorites, as best we can tell, land all the time over the entire surface of the Earth. Oceans, jungles, ice caps, and they're tiny, really tiny, hence the name. It's probably not an intellectual leap. So smaller than you would see with the naked eye. And if you're interested in the science behind this fascinating aspect of extraterrestrial material, I highly recommend a marvelous book called Hunting for Stars by Michel Mauret, Maurette, a French author and academic who studied micrometeorites for many years. And I think it's out of print, but quite easy to find. So Michel examines all the different strategies that you could use. If you accept the theory that micrometeorites fall all the time, all over the surface of the Earth, how are we going to find them? Well, one of the popular methods is to scoop out carefully all of the material inside your rain gutters.
Right.
We don't actually have rain gutters in Tucson. We just don't have any rain here. But if you lived in a place with a more reasonable climate, you probably have them. The theory is this. It's not that they fall into the gutter. It's that the roof of your house is a fairly large target in the scheme of things. And everything that falls onto your roof would probably over time be washed down into the gutter. And then if you carefully scrape out that material and then go through it with a very powerful magnet, you may recover some micrometeorites. And the best way to examine them is through a powerful microscope. So it sounds good so far, right? Here's the bit where the disillusion comes in. You will probably almost certainly find loads of tiny little things in your gutter that will stick to your magnet. And some of them will be bits of your gutter, and some of them will be other strange, unexplainable bits of metal that have fallen on your roof, which strangely enough really does happen. And mixed in there, hopefully, probably will be some micrometeorites. And examining them under a really powerful microscope is the best way to look at them. And you will notice, if you find any, that some of them are oriented. They have a rounded front, like a little shield, like a little tiny heat shield on a miniature Apollo capsule. And if you were to do an online search for photographs of micrometeorites, you'll see some pretty extraordinary images. And they really are out there. It's an exercise in patience, but it is a way in which almost anyone could hunt for meteorites. You don't necessarily have to get 5 vehicles and go across the Australian outback wearing flying helmets. Put a sheet out like
for 6 weeks during the summertime.
Right.
Yeah. No, I've been wanting to do this, but it's just like I need another hobby.
Yes.
Yeah. But
actually, it's very interesting, though. If you think about, Fraser, your interest in astrophotography and how you're photographing the most massive things as far away as could be. And then if you were to photograph micrometeorites as well, you're photographing the most minute things, but they've also traveled a great distance.
Yeah. So the book that you're mentioning, and I apologize, and in fact, I'm planning to have the writer as a guest, but he's got pictures of every false positive as well.
Oh, excellent.
Yeah, so you can see what a piece of coal dust looks like and a piece of pollution and glass particles, and he's seen everything and identified everything and essentially has gotten the scientific community to agree that what remains are definitely from space.
So, excellent.
Yeah.
Well, I'd love to see that. Do you remember the author's name offhand?
I will send you a copy. I'll send you the info after.
Please, thank you.
Dig it up, and I'm sure I'll make a connection for you to be able to talk with them. Let's move into space exploration, because I mean all this meteorite stuff is fine, but so you you expressed that you spent some time with Rick Tumlinson with his Deep Space Industries. Of course, the other one is Planetary. What's the name on
Planetary Resources?
Planetary Resources, yeah. And there was almost a bit of a land rush, a little bit of a boom there in space-based mining companies, and then I think that sort of stalled out a little bit because it turns out space is difficult. Where are we in our quest to harvest resources from the solar system directly?
I love that question. We're well on our way. It's definitely going to happen.
Already there.
And we're
starting with the Earth.
Yes. Yeah. Well, and if you think about the OSIRIS-REx mission, which is based here in Tucson, and the principal investigator of OSIRIS-REx, Dante Loretta, is a wonderful friend and colleague of ours. This is a mission, a robot spaceship that's going to Asteroid Bennu. Well, is at Asteroid Bennu, is now figuring out where is the best place to collect material from. And it's going to scoop some of that off the surface, and it's going to bring it back to Earth, and we're going to be able to study it. So that is asteroid mining on a modest scale, although not modest in terms of achievement. To build a robot that could go all the way out there, find the asteroid, survey it, extract material, and bring it home is a Herculean scientific achievement. It's really extraordinary. So that, in a way, I mean, you could argue it almost diminishes the value of meteorites. Not really, but
go get them from space.
Well, this one's been melted by the atmosphere on the way in, so it's special.
Yeah.
But you could look at OSIRIS-REx as the first real solid step towards asteroid mining. And it's not. Go ahead, please.
I was going to say, I mean, this is sort of my current obsession. Is like everyone is so excited about how SpaceX is demonstrating the power of reusable rockets. And we're at this time suddenly where rocketry is becoming so inexpensive that you can launch satellites into space, and they're going to build a global GPS system and a global internet satellite so we can all have internet in the middle of nowhere, which is wonderful. I want that. Yes, please. But in fact, the reality is that I think this is just a blip, that 20 years from now, 30 years from now, we won't be launching very many rockets anymore. We won't need to, because all of the raw material that we require for our space-based infrastructure is out there in space. And the reality is that it's ridiculous to launch anything from this gravity well out into space. A kilogram of metal here on Earth is going to cost you $1, Well, a kilogram of metal in orbit is going to cost you $2,000. A kilogram of metal on the surface of the moon is going to cost you $100,000. So there is an enormous economy of scale if you can figure out how to make the spacecraft go and extract the resources and be able to build these structures. And also, you can build things in space which are far more appropriate for space, because, you know, with the James Webb Space Telescope, it's got to be built on land, it's got to be fold up, it's got to handle the rocket launch, it's going to be shaken around, and it's going to get up into space, and it's got to unfold, and everything's got to go right. When you could just build something in space from day one that's never had to exist in the Earth atmosphere under the Earth gravity and have a better system. So I actually think that, you know, obviously Deep Space Industries, Planetary Resources, whoever cracks this, that it is going to leapfrog the entire need for rockets. The only thing we're going to need rockets for is to launch the meat to go up into space to, you know, to be the space tourist. But apart from that, we're not going to need any of that.
I was just going to say the same thing. Won't it be fantastic when we get to the point where the only things that we're really launching into orbit are the people?
Yeah.
That everything else is being manufactured there. So you and I are so much on the same page with this. You've hit on some of my favorite topics and some of the most important topics for long-term spaceflight exploration and settlement. When we get to the point where we don't have to take what we need with us, the entire circumstances of construction and settlement change. And this is where asteroids become so important. And that is why the study of meteorites is so important in this story. We know from studying meteorites, that's actually why I picked this one, because the surface of many or most asteroids will be made of this type of material, chondritic material. There's a lot of variety out there, not all of them, but this is what we expect many to look like. And what have we got in here? Well, iron and nickel to start, all sorts of silicate materials. And if we look at some different types of meteorites, carbonaceous chondrites, very ancient meteorites that have been less altered over time, we find that some of them contain water, carbon, salt, amino acids, other trace elements and metals. All of these things can be used in space and we'll need them. One of the most challenging things that I think the average person would not really register is that every bit of water and every bit of oxygen that our astronauts on the International Space Station have to consume, all the materials originally have to be taken up there in a rocket. Yep. Spacesuits, food, spare parts, everything that you need. So when we get to the point where we can make some of those things, the heavy things, as you said, the metals, the structures, in space, extract them from asteroids, and perhaps use 3D printing or other contemporary technologies to make the parts that we need, everything changes. And this is actually my favorite bit of the whole story, because I'm a huge fan of Babylon 5, and I just love the Earth Force Alliance destroyers, and they're not at all streamlined. They've got all these extra bits and pieces on the superstructure and these giant cannons and everything pointing out. When we start building ships in space, we can do that. They won't ever go into the atmosphere. They will always stay in a vacuum, so they don't have to be streamlined. And that's exactly what you said, Fraser, when you said we won't have to build things here for space. We can build things in space to be used in a practical way there.
When I was doing some work with the X Prize a couple of years ago, and so we were building this platform so everybody could make their own X Prize. It's called Hero X. You can still go there. And my idea was I wanted to do a challenge every year or whatever, which was a self-replicating robot challenge. So whoever could make a robot make the most of itself in as automated a fashion as possible would win this year's challenge. I mean, I never got it off the ground, to say, but I still think that's the future, right? If we can get to this place where you send one robot and it goes to an asteroid, builds more copies of itself, harvests the resources that it needs, shuttles them back to where we need them, then like, what does expense even mean anymore? Because you've sent your cost was one robot, and then everything just starts, as long as you're patient, it's like planting one seed. and then you get a forest. So I think it really feels to me like that is the future. There's just a million, obviously, technical challenges to get there. But there are some actually quite incredible developments that are happening, like things like Made in Space. They have this great 3D printer on the International Space Station. They could build wrenches and little doodads and stuff like that. But they're building this Archanaut, which is their little spacecraft, and it takes sort of vats of raw material, and then it will extrude girders like a spider. And then it will sort of, like pull them out of its mouth and then pull out the girder, spin the girder and then spin a little bolt and then spin a nut and then attach it together with its 3 arms and then extrude another girder, right? And so you can see, again, as we start to learn these lessons, what it means to live in space, to build things in space, facilities, infrastructure, that kind of thing is all changing. So how far away do you think this stuff is? Now that you've been on the inside track on some of these organizations, how far until space mining becomes a thing?
It's happening so quickly. I feel that we almost have the technology, we almost have all of the pieces now. And of course, the distances are still quite significant in getting to the asteroids. We probably, in most cases, or all cases probably, would not be going to the asteroid belt anytime soon, because average distance from here to the asteroid belt, as you know, is about 250 million miles or more. So asteroids that are in an erratic orbit, near Earth asteroids that come closer to us, become much more attractive targets because they're so much closer. But I mean, definitely in our lifetimes, in not very many years, I think. And I have to just go back and say OSIRIS-REx again. We've just done the first step. The robot's there at Bennu now, at Asteroid Bennu now, talking to headquarters here in Tucson. It's an amazing achievement.
Not to mention Hayabusa.
Exactly.
2 of them, right?
Yes. So I have a special affinity for OSIRIS-REx because I went to visit it when it was being built in Denver, and I did an episode of STEM Journals about it. But it's not the only mission, but it's one I'm very close to. So that shows that we can do it. That shows that we can send a robot to an asteroid and collect material. And from there, it's a very small jump, I think, to extracting material using microfoundries, as has been proposed by Deep Space Industries, and 3D printing and other technologies to build the parts. And then if you take that one step further and talk about the self-replicating robots that you discussed, you could have an army of these guys out there building stuff for us.
Yeah, harvesting the water, making oxygen, building rocket fuel, really whatever you want.
Yes, and you touched on something else that's extremely important. Not just the hardware, but the water and the oxygen that we could use on the International Space Station now, or in the very near future, when these raw materials, when we're processing them from asteroids or from the moon and Mars. But then the progeny of the ISS, the next generation of permanent space structures and settlements that are going to come, if we can get the raw materials, the water, the oxygen that we need from nearby, it makes it much more reasonable and believable that they could continue in perpetuity as self-sufficient groups.
So why are the companies who are trying to do this having such a hard time?
It's such a massive challenge. It's the cost, the hardware, the risk. And when you consider that until quite recently, nearly all of the significant accomplishments in spaceflight were the work of major governments. So NASA through the United States government, the Russian space program, and the other big achievements that have happened. But let's go back to the Cold War, Mercury, Gemini, Apollo, America versus Russia. This is a monumental undertaking. This is almost unlimited resources being thrown at this space race of who's going to be the first to get to the moon. And it's completely different now, where we have entrepreneurs and we have some very successful business people who, in some cases, as you well know, are putting their own fortunes into this. And I find it very inspiring, because if you go back and look at some of the great inventors and the great leaps forward that have been made in technology in our history, the Wright brothers being a fantastic example, they were entrepreneurs. They were doing it themselves. So the phenomenal cost and the new technologies that have to be invented in order to make particular things happen are enormous challenges, of course. But look at the strides that have been made in the past few years. The Virgin Galactic flights, the reusable SpaceX rockets, Worldview here in Tucson doing its test launches, which leads on to another really interesting topic, which is space tourism, which is another thing that is so close to happening. And I have a very close friend, Jim Clash, who is a celebrated adventure writer who was a very early person to sign up for Virgin Galactic years and years ago, when I think some of us probably looked at him and thought, gosh, you really are very optimistic or a bit crazy. And now look at the successful flights that they just had so recently.
Like maybe this year, maybe he'll get a chance to fly this year, next year. Maybe.
Soon, I think. Very soon. And it's so exciting for someone like myself who has vigorously observed and vigorously observed spaceflight for my entire life. I was born in 1961, just a very short period of time before Yuri Gagarin made the first spaceflight, became the first human to leave Earth. So I'm the same age as manned spaceflight, human spaceflight.
Right.
And there was that long, exciting period in the 60s and 70s with Mercury and Gemini and Apollo and Skylab. And then, of course, things changed. And we were doing much lower Earth orbit operations with the space shuttle and going towards the ISS. But now we're at the exploration stage again. And it's not just one or two entities.
Right.
It's not just Russia and the States competing against each other. It's countries and companies. And when the private sector gets involved in something, it's going to have to pay or it's going to stop. There is not unlimited funding for these things.
Yeah, I mean, I could spend the rest of this episode rattling off all of the companies that are participating in this new space race. And some won't survive. Some, but when you've got, China, you've got Russia, you've got the US from a country standpoint, you've got India, you've got the plans from folks in the Middle East, and then you've got collaborations between, say, the U.S. and New Zealand, and there's a new launch facility that's going to be here in Canada. And then you've got all these companies, not just SpaceX. Blue Origin is going to be hot on their heels, plus Vector Space and a lot of really interesting companies that most people probably haven't even heard of, and then other ideas as well, like Strata Launch and stuff. So we're
Isn't
in this.
That something?
Yeah. So
don't forget the European Space Agency, which is a consortium of many countries working together. And this is one of the really great hopes in spaceflight. Wouldn't it be marvelous if getting out there and exploring and harvesting the riches of space actually brought us together more? And the European Space Agency is a marvelous example of that. 16 or 17 countries working together on projects of tremendous scope. And where we were last year in Australia, there's a vigorous and growing Australian independent space flight movement.
They just got a space they got a space agency.
And lots of nice, dry, flat, open spaces in Australia for launching rockets, just FYI.
Yeah.
Hello, Australians.
So let's talk about your new gig. Your new job.
Well, I have the most exciting job on Earth, I think, just about. I have been involved with the National Space Society for many years. And a little background, the NSS was founded in 1974 by Wernher von Braun, the great rocket scientist who built the Apollo rockets. And in the 80s, it merged with the L5 Space Society. And we are now a global force. This is an international organization with many thousands of active members and an enormous number of affiliate members. We have about 50 chapters around the world. And the thing that really drew me to the NSS is it's not just a club for space enthusiasts. This is a serious organization that is promoting the concept of humanity as a spacefaring civilization for all time. And our leadership is made up of engineers and former astronauts, scientists, many NASA employees, past and present, and employees of many other major space-related companies. So we have a leadership made up of very experienced people who understand the workings of the spaceflight world. And we have actively lobbied for spaceflight friendly legislation in the States and provided a learning platform. We have an enormous educational division that helps bring students from overseas to space-related functions here in the States. And every year we host the International Space Development Conference, which rotates from city to city. This year it'll be in Arlington, Virginia, from June 6 through 9. And this is a very large, fascinating, brilliant, and engaging meeting of spaceflight professionals and enthusiasts, young and old. And we have hundreds of students come from overseas for this, hundreds of future spaceflight professionals. And this year is going to be really something special. We have NASA Administrator Jim Bridenstine as one of our keynote speakers, and we have Lori Garver, and we have astronauts and engineers, extraordinary lineup of speakers, as extraordinary lineup of speakers as you could get in spaceflight, I think, just about. I mean, Al Worden from Apollo 15 is coming to address the student group one morning. Boy, are they in for a treat.
That's amazing. And so really what? So the goal is to get students enthusiastic and excited and involved in space exploration early on?
It's part of it, but we're by no means just a student organization, although the educational wing is a big part of the NSS. But the more active space flight professionals in leadership are engaged in advising and helping with sensible long-term space flight policies and encouraging industry and innovation as well as learning. So the student wing of the NSS is probably best represented at ISDC, although we are also involved with the Space Settlement Design Contest and competition. They're two separate ones that encourage students from all over the world to solve real problems. How would we build habitats using this form of technology? And that's something that I'll be involved with in July. I'm very honored to have been invited to go to Kennedy Space Center by Anita Gale, who's the secretary of the National Space Society, to be one of the judges of the International Space Settlement Design Competition, where I will be meeting students who are addressing these challenges, these hardware challenges. How do we build a safe habitat that settlers, astronauts can live in?
Molo 1113 asks, how do you feel about the return to the moon?
I feel great about it.
Yes, please.
I'm sorry it's taken so long, but is
it going to happen though this time?
Oh yes. Why are there questions about whether or not it happened last time?
No,
let's not even get into that.
No, not that. No, I'm saying like we were gonna go back to the moon back in like the early 2000s, and then we're gonna go to Mars, and then we're gonna go to an asteroid, and then we're gonna go to Mars again, and now we're gonna go to the moon, and we're gonna do it in 4-5 years, and like there's some challenges here. So
yes, definitely, but it's the first time in a significant number of years that a leading American politician, in this case our vice president, has really thrown down the challenge and said, okay, we're going to be there in X number of years. And you can't help but think back to President Kennedy in the 1960s, early 1960s, giving us the challenge of getting to the moon before the decade was out. So I'm very encouraged to see strong support from our government and other governments for long-term space exploration. It's critical. It's not a hobby. It's not a fun thing that we should maybe be doing. Mm-hmm. It's critical for our survival, and it's very important for our progression technologically, and it also offers many returns. So that's a direction that has been presented by the United States government, which is wonderful. I'm all for it. There are many other opportunities. There are asteroid mining that we've already discovered. There are flights to Mars. There are all sorts of opportunities to build things in in low orbit space and high orbit space. All the multitude of opportunities are very different from what we were presented with in the 1960s and 1970s, when most of American space-related resources were going in one direction. And now we see a multitude of projects worldwide, many different governments, many different entrepreneurs. So yes, I'm all in favor of going back to the moon, and I really look forward to seeing some more moon rocks come back.
Well, I think from my perspective, there is a lot of hidden problems that people tasked with this job are waiting to uncover, are in political problems in trying to get various support from different parts of the United States that have been very used to jobs coming to their regions, that there are hardware manufacturers that have been working on their projects in a certain kind of cost plus accounting system, that there are safety features that still need to be figured out. And as long as the safety is there, I think this will be an opportunity to shake out what's wrong, what's missing, and get a much better sense of what it will actually take. And then at some point, though, someone's going to say it's going to cost more money. And that's when I think the rubber's really going to hit the road, right? Will they be able to deliver on the money?
Whenever the discussion of long-term spaceflight and exploration comes around, at some point it usually gets to the cost, and understandably, because it is the price tag is really high. It seems when someone just says, well, it cost X billion dollars to develop this rocket and to go to the moon, and it cost all of this, but you know that the returns are enormous. The new technologies that have been developed, the fact that we began to really understand what the greenhouse effect is and what global warming is through studying Venus, we would not be as far along in our concerns about the long-term environmental safety of Earth were it not for space exploration. And here's a number that will knock your socks off. About $350 billion a year generated by space-related industry and tech. And that's just where it is now. And then if you look really long-term and we start getting into some intriguing areas like space solar power, where we could actually be generating energy in space and returning it to Earth, and long-term possibly even moving dangerous, toxic, heavy industry off Earth into orbit or onto other astral bodies, you're looking at massive long-term benefits for humanity. But the immediate returns are new technology, jobs, financial return, enormous financial return from space investment. And the less tangible, the less measurable, the pride and the amazement that we have that we were able to send humans off our little rocky body out there and bring them back for the betterment of ourselves, not just in a financial way, but in a more spiritual way, in the sense that we have gone on the great adventure and returned safely, and now let's prepare another great adventure. It's part of who we are. We're never going to be content to just sit here and look up at the sky. You're a devoted astronomer. You know what that feels like.
I think that all of those reasons that you have presented have been tried before. And I think that is, all of the side benefits that we get, all of there's no question, whatever it is, a 10-to-1 payout from the money spent on STEM and space exploration into the larger economy is all absolutely relatively easy to justify. And yet, with that benefit that's been very clearly calculated time and time again, it's still a hard sell.
Mm-hmm.
So
to some,
yeah. And so I do think that I think, you touched upon this earlier, that the private industry getting in there, like when SpaceX launches their Starlink system and they put 2,200 satellites up and they overnight offer a worldwide high-speed internet that allows us to all dump our cellular phone providers, that will pay for an enormous amount of space exploration. So And what made that possible was relatively inexpensive, reusable rockets that they can bring down the launch costs. And then when they have all of that money, they're able to bring down those launch costs some more. And so it really does feel like we've known the benefits, but the various governments of the world haven't really been able to take advantage of it in the way that the private industry, like, hats off to Elon Musk, and a lot of the other people involved with SpaceX and Bezos as well, to open everyone's eyes to what's possible and what can come. But I think for me, the incentive that I think is the best is just the fact that we are sort of ruining our local environment, and space is the worst already. So if we can take advantage of space for acquiring our resources, doing our heavy manufacturing, drilling for resources and building them out there, we can let Earth do the thing that it needs to do the most. Like, it's the best place in the universe right here. And so let's,
that we know of.
No, I will throw down with any alien who says their planet is better, for me. Because all my previous life forms evolved specifically into this ecological environment. So we need to and we're ruining it, right? We're living in our own waste, and we are raising the temperatures. We are polluting the environment. We're filling the oceans with plastic. We're doing all this stuff that we really don't need to. Once we master space, then the universe, until we find some other life form and we have to negotiate a treaty. But until then, the universe is raw material so that we can make Earth a better place. And
I love that. That's a marvelous.
That's
Bezos' marvelous thought.
Yeah, that's Jeff Bezos's feeling on this. Not Musk is, let's colonize Mars and let's have a backup plan for humanity. I don't think there's a backup plan for humanity. That Earth will always call to us, and we'll always want to come home to this place where you can see oceans and forests and birds and all of that stuff, right? That you can live in this. Mars is like the worst. It's just like this dry, cold, airless desert where you live underground and check yourself for cancer all the time.
And the concept that you just related, this dream, this desire to always come back to Earth, is such a familiar theme in science fiction.
Yeah.
Even in all sorts of films and books, that the individual has gone on a journey, or the human race has gone on a tremendous journey of generations, and there's this dream, there's this desire to return back to a pristine Earth. And you touched on something that makes me want to recommend this wonderful book to you and your readers. This is just released very recently. It's Space 2.0, and it's written by Rod Pyle, Pyle, who's a very well-known, very highly admired spaceflight author. I'm sure many of your readers will know that I think this is his 15th book on spaceflight. Forward by Buzz Aldrin, and Rod is the editor-in-chief of Ad Astra, which is our National Space Society official magazine. So I know Rod very well. We're friends, full disclosure. It's a really fantastic book about how we got here in terms of spaceflight, how we got to this point, and what is happening now, and what's likely to happen in the future. And he's a very practical, technologically savvy science writer. So this isn't science fiction, this is science fact. And it's so illuminating. And there's a marvelous bit where he talks about what you were just saying, Fraser, which is space is a horrible place. And that for us to do anything as humans, we very weak, fragile humans have to carry a tiny bit of our Earth environment with us wherever we go.
Yeah.
Whether that be a spacesuit or an international space station or a habitat on Mars, which we don't have yet. But it makes you appreciate what we do have when you think that if we go anywhere else at all, we've got to take a replica of our environment with us so that we can survive. So
a pale imitation.
A pale imitation, yes, with no seagulls or sea breeze, or although some of the research I've been doing recently on projects like the Lunar Mars Greenhouse, which is a fascinating hydroponic facility that's going to allow fresh fruit and vegetables to be grown in space, does give you hope that there would be some comforts, even in the fairly near future, in space settlement.
Yeah. Yeah, no, I am, but I am really excited. I mean, I got a chance to interview Rod. It was a great conversation. He was wonderful, and I loved his book, and just that this time it feels so different. This time, here we are with the establishment that has been doing things the way it's always been done, and an entirely new way of going about it as well, that is going to both use the establishment as its customer base to take the next step and to invigorate or destroy the existing way of getting to space. But no matter what happens, we're not going to stop this time around. It's going to happen.
You're so right, and
Yeah.
I love your enthusiasm, and I have the same enthusiasm. And I'm working with the NSS every day, and I'm seeing new reports and new numbers and new position papers, and it's all happening around us.
Yeah,
it's happening around us as we speak. There are startup spaceflight companies, new and old and established aerospace giants, all building and designing new things. And this is touching on something we spoke about earlier, but to me, it's the diversity. It's being attacked on so many different fronts now. It's not just a couple of missions that are being planned. And you have heavy launch vehicles being designed. You have habitats being designed that are going to be installed on the moon and Mars and other worlds. And then we've got things for leisure. Space tourism is a real thing, as you know.
Yeah,
that we're going to be seeing a lot of. And in the same way that the price point of getting raw materials into space has plummeted, and I actually got some numbers on this yesterday from our board, $10,000 to $25,000 was typical with what we would say heritage launch vehicles, maybe in the 60s and 70s and on into the 80s. And the estimate now is $877 per pound.
Oh, there you go.
Through SpaceX. And it's going to be less than that soon. And then again, as we touched on earlier, once we start manufacturing things in space through asteroid mining and other resources, then the amount of things that we have to take into space will decrease significantly.
Yeah.
So yes, I'm absolutely with you. There's this feeling of optimism, this excitement along the lines of, well, what's the new bit of space news today? Whereas when I was a kid, or even when I was a kid during the Apollo era, it would be, well, every few months there'd be another bit of news and there's another mission. And then in the long gap of the 80s and 90s, when we had less going on and we had Skylab and the shuttle missions and the building of the International Space Station, but all things within Earth orbit. And now we're looking far away again.
Oh, I guarantee, as a person who sort of has to drink from the river every day of space news, and I am overwhelmed by the amount of amazing stuff that's happened, and I can't wait for what this is all going to become. So, Geoff, we've reached the end of our time. I want to give you a chance to let people know where they can participate in more. So first, if people want to learn more about the National Space Society and join up, where can they go? What should they do?
Wonderful. Thank you for the opportunity, Fraser. So we are NSS.org, nationalspacesociety.org. We have an introductory membership rate of only $20. And there are all sorts of attractive packages for students. And our members get this beautiful magazine at Astra, print and digital editions, which is published quarterly, award-winning magazine. And we sponsor the International Space Development Corporation Conference, International Space Development Conference, ISDC, which happens June 6th through 9 this year in Arlington, Virginia. And all of the information is on our website, nss.org. And we have a very active Twitter and Facebook social media presence. So we're NSS at NSS on Twitter and National Space Society on Facebook. And I would encourage you to reach out and join us and become a meaningful part of an international organization that is making change, not just today, but far into the future. And I find it so inspiring that citizens, people who are interested, who are not even in the aerospace or tech world, can feel an active part of this most important of all missions.
And if people want to follow what you're up to specifically, personally?
Well, thanks, Fraser. I'm Geoff Notkin on everything. That's GeoffNotkin. And I'm very active on Twitter, Facebook, Instagram, and YouTube. And my company is Aerolite Meteorites, and we're aerolite.org. That's AEROLITE, which is an archaic British word for meteorites, in case you were wondering.
Aerolite is an archaic, really?
Yes.
I didn't know that.
Yeah. So once I got a intriguing and slightly annoying message from a boy who was 7 years old, and he had purchased a small piece from us for his birthday, and he wrote to me and he said, "I just wanted to let you know that I understand that the word aerolite means meteorite, and so the name of your company is really Meteorites, and I think that's redundant." And I thought, wow, that kid is way too smart for his own good. And I wrote to his parents and I said, when your boy's 18, you tell him to get in touch with me. You can come work for me.
Yeah, that sounds great. All right. Well, Geoff, thank you so much for taking the time to talk with us today. Thanks, everyone, for watching us. Thanks, everyone who asked a bunch of questions. Thanks to the moderators for keeping it civil. We will see you all next week. Thanks, Geoff.
Thank you.